Well, I said I should have got everything ready. All right, so do y'all remember a couple weeks ago when we first started talking about these angle relationship things? We were talking about, so if you've got two lines that are parallel, right, like so, and you have a transversal, then it creates these angle relationships, and then you know that the ones that are corresponding to each other, like 1 and 2 right there, are congruent to each other, right? So we come up with this geometric, well, hello, Jared, I've marked you absent. Were you in the bathroom? Oh, your bag is there. Alrighty. I didn't see it. I didn't either. Sir? This Friday? Of course. No. We're gonna do some scary math. No, it's gonna be a regular day. I mean, if y'all want to bring food, I'm okay with that, but we're still gonna work. So, okay. So we came up with this postulate that we said, if these two lines are parallel, then angle 1 and 2 corresponding angles are congruent, right? And that's the corresponding angles postulate. That's what that is, corresponding angles postulate.
Good morning.
Yes, ma'am.
Judith Contreras needs to come to the office, please.
Okay.
Thank you.
When Judith gets back, we're going to quiz her over it. We won't take no for an answer. She won't answer. We'll just waterboard her or something until she does. Okay. I'm not waterboarding kids, okay? I forgot I was videoing. All right. So, yeah, somebody's going to see that and be like, Miss Barnes been waterboarding kids. Okay. That's corresponding angles. Now, we have the same thing going on with alternate interior, alternate exterior, consecutive interior, consecutive exterior. All of those have their own little postulate, right? That says, if I know these two lines are parallel, then I know this stuff about these angles. Well, today we're going to work backwards. So today we're going to say, hey, this angle and this angle are congruent. Guess what that means? That means that these two lines must be parallel. If these corresponding angles are congruent, then this line and this line has to be parallel. It's the exact same concept. You're just going through the back door instead of the front door. And our reason would be the converse. Remember, converse is when you switch your P and your Q, right? So it'd be the converse of the corresponding.
I'm sorry for interrupting, teachers, but I need any junior who wants to take the PSAT tomorrow to come see me now. It is the last chance that juniors will have to ever take this test, and some scholarships ask for the score, but also it is the pre-qualifier for the National Merit Scholarship. So any junior who did not take it 2 weeks ago and wants to take it tomorrow, you need to come see me now. Thank you.
It's going to be one of them days that we can't get anything accomplished because of all the interruptions. Okay. So the converse is we're working backwards, right? We know the angles are congruent or supplementary or whatever. And so that tells us the lines are parallel. Same stuff we were doing, same ideas. We're just going backwards to do it. You see what I'm saying? Okay, so if you look at your 3-5, right? So we're going to zoom in on this right here. Not this one. This. Oh. Trenton, will you bring me a 3.5 from over there, please?
A what?
3.5. That laying over there. I forgot to grab a clean one. A clean copy. Huh?
I was confused about what you were asking.
Yeah, I was too. I'm like,
I'm so sorry. I am so sorry. Well, dude, hasn't come back yet. Okay, so in these directions for this right here, it says, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So in number 1, they tell us angle 3, which is right here, is congruent to angle 7, which is right here. So number 1, what is their transversal? What are they attached to? Which line are they both attached to? So everybody says that. That's an L. That's a cursive letter L, not an E. Yeah, it's an L. So this right here is an L. This guy right here. Okay. Huh? I know. It looks like a E. I see where y'all get an E, but it's really an L. Okay, so that is an L right there, and they are attached to that L. Now, what are the other 2 lines that make them? A and B. So then we're going to say, okay, are they on the same side of L or alternate sides? Alternate. Are they inside A and B or outside?
inside.
Here's A and B. Are they inside? Or are they outside?
Oh, inside.
They're inside. So they are alternate interior angles. And we know alternate interior angles are congruent if the lines are parallel that they're inside of. So that tells us that what lines would be parallel in this situation? A and B. So we would write that as A is parallel to B, like this. Okay? And what's our justification? Converse, yeah, it's over there on the counter. Converse of alternate interior angles. And it's the converse because we're going backwards, right? We're not saying these lines are parallel, so these angles are congruent. We're saying these angles are congruent, so that means these lines are parallel. Okay, so number 2 is asking about 9 and 11. So angle 9 is this guy right here. Angle 11 is this guy right here. What do we know about them? What's their transversal? M. What's their lines that their other 2 lines are connected to? A and B, right? So if we're talking about lines being parallel, it's going to have to be A and B. Okay? Not their transversal, the other 2 lines. Now, what are they? Like, what's their relationship to each other, 9 and 11? They are corresponding. So if we go to to number 2, same answer. A is parallel to B again, but our reason is different. This time it would be converse of corresponding angles. Converse of corresponding angles. Do y'all see? Does it make sense? Okay, so then what's number 3 asking about? 2 and 16. So angle 2 and angle 16. 2 and 16. So what transversal are they on? A. What are the other 2 lines that make 2 and 16? L and M. So we're not talking about A and B this time. We're talking about L and M. So if we're talking about 2 lines being parallel, L and M is who it's going to be. And we know that these 2 are congruent. What kind of angles are they? Alternate exterior. Good job, Preston. Alternate exterior angles. and alternate exterior angles are supposed to be congruent if the lines are parallel. So what lines are parallel? L is parallel to M. What's our reason? Converse of the alternate exterior angles theorem. Huh? Yeah, all of these are going to be converse, every one of them, because we're working backwards on this whole thing. We're working backwards. Okay, look at number 4. So it's different. On number 4, it says 5, that's this guy. 5 plus 12, the measure of 5 plus the measure of 12 equals 180. All right, Missy. What's going on? What have you done?
I wake up late.
Oh, tardies. We didn't have to waterboard Judith to get the answer.
I won't walk the line.
Yeah. Yeah, don't watch the live.
The people watching stuff. They already contacted the authorities.
Judith has a lot of tardies. Okay, I love y'all. I just want y'all to know that. This is such a fun class. I have the best classes this year. In every class, I'm like, this is my favorite. But then the next class comes, I'm like, no, this is my favorite. Like, I just love all my classes.
Because we were on the board, right?
Yeah. That's exactly the reason.
Because goatees are evil.
Yeah, goatees are evil. That's why I shaved.
I've always felt like goatees were evil.
But every villain has one.
Yeah, goatees. And if you'll notice, people who wear goatees often drive white vans. And they are definitely kidnappers or terrorists. One of the two.
And murder. I can't.
I was going to try to help you out, but I wasn't sure what words you were going to say.
I say it perfectly fine,
I do that too. And motorcycles?
Yes.
Mm-hmm. Yeah, and you can't trust anybody who rides a motorcycle. No. Okay.
That's fine.
All right, so back to this. 5 and 12. It says that they add up to 180. Now, what kind of angles are they?
Same side.
Same side or consecutive interior, right? And what do we know about same side or consecutive interior angles? Well, they should add up to 180 if those lines are parallel. That tells us that angle, or that line L and line M are parallel. So line L is parallel to line M. And how do we know? Consecutive or same side. Converse of consecutive interior angles theorem. Right? And like Preston and I were talking, all of these are going to be converse because we're working backwards on all of them. We're starting with the information about the angles and going back to saying that the lines are parallel. Emily, can I see your shirt? Can you back up a little bit so I can see you? Oh, okay. I could just see this little part up here and I couldn't figure out what on earth it was. But when she backed up, I could see there were people and stuff and it made a little more sense. Okay. All right, now on 5 through 10, they're telling us to find the value of x so that L, and look y'all, it didn't print the M, L is parallel to M. So they're saying make the assumption that L is parallel to M. If it is, what would x be? Okay, so what we have to do is look at those angles that are given and say, all right, what's their relationship? And then we're going to write an equation based on that relationship. So what would the relationship be between these two angles right here? Same side interior. And what do we know about same side interior angles? They're supplementary. So our equation would be 2x plus 6 plus 130 equals 180. And then we just solve it, right? So what would we do to solve that? Y'all got nothing? Add the like terms, right?
Oh, I just don't.
And then we're going to subtract, right? And then divide by 2. And we do get, what did Lyndon say? 22. We're done. Because the direction said find x. If the direction said find the angle measurements, we'd have to go do a little bit more work. But it didn't say that. It said find x, right? Now, alternatively, we could have just done 180 minus 130, which would have gave us, what, 50? And done 2x plus 6 equals 50, and that would have been okay, too. Either way is fine, okay? Okay, number 6. Tell me what you know about those two angles they gave us information about. They're alternate exterior, which means what about them? They're congruent. So when we write our equation, it's going to be 3x plus 10 equals 4x minus 10. And now we just need to solve it. What do? And if you can do 2 steps at one time, you can do 2 steps at one time, okay? If you can add and subtract both things at the same time if you want to. So that gives us 20 equals x, and we're done. That's it. Y'all good so far? Okay. What about number 7? What do we know with those two angles? So that you know it's this angle here and this angle here. What do we call them? Alternate interior. Man, y'all are on this. And what do we know about alternate interior angles? They are congruent. That means, how do we write this equation? 6x plus 4 equals 8x minus 8. And then we would solve it, right? So what do we do to solve it? Subtract 6x from both sides. Then what? Add 8 to both sides, right? So that cancels the x's over here, the plain numbers over here. That gives me 2x equals 12. Right? Because I'm going to divide by 2. X equals 6. So far, so good? Okay, look at number 8. Tell me what you think. You know what? Try number 8. Let's see if you can get it right. You try it and see if you can do it on your own. None of y'all are in my engineering class, are you? No. Hudson, why does depressed Mr. Krabs not actually look like Mr. Krabs? Oh.
Because he's depressed.
Oh, it's Krebs, not crabs. I see that now. Okay, I understand. Alrighty. I was like, I'm very confused by this. I do not like SpongeBob at all. My daughter loved SpongeBob when she was younger, and I just thought it was the absolute stupidest show I'd ever seen in my life. The only thing I think probably tops it are the adult cartoons like Family Guy, King of the Hill. I hate South Park. I do not like adult cartoons. I just think they're dumb. It's not that I'm against animation. It's not that I'm against adult humor, because I'm not on either one.
It's the way it happens.
I just don't like it in general. I just don't, I just don't care for it. I think it's just stupid. I don't like stupid humor. I like funny, witty humor.
Like, King
SpongeBob.
I don't like stupid humor.
was funny because like Bobby's like, but
So first of all, that was a great impression. I've watched a lot of it. My husband and daughter both like it, so I've seen it a lot. I just don't care for it.
Oh my God, South Park is amazing.
no, South Park is really dumb.
South Park is really dumb. I mean, like, it's probably the dumbest of all of them. Okay, we got to continue. Did y'all get number 8 done? What'd you get? X equals 2?
Which makes 0.
What do you mean it makes 0 sense?
There are 2 angles.
You're right.
8.
You are right. It does not make any sense for X to be 2. But, remember, not drawn to scale.
That could at least make
I know, I agree with that. Just remember, not drawn to scale. So did everybody get X equals 2 on 8? I'll go over it if you need me to. It's up to you. Okay, so let's look it over real quick. These two alternate exterior angles. Anytime you're talking alternate, that means they're going to be congruent. If they're congruent, that means their measures are equal. That means we can write an equation that shows they are equal to each other. If we're showing they're equal to each other, we're going to solve this by subtracting x from both sides. That's going to give us 3x equals 6, right? If we divide both sides by 3, x equals 2. Now, like Landon said, this is an illogical answer, because if you put 2 in there, you're going to get that's 8. If you put 2 in here, you can get that's 8, which is...
At least they're the same.
They are the same, which means we did our math right. But they're clearly obtuse angles, and they're clearly way larger than 8 degrees. But not drawn to scale, right? Not drawn to scale. They don't even try. They don't even try. All right, y'all try number 9. See if you get that one right. Pay attention to the relationship. Don't just randomly write up an equation. You have an answer yet? What you got? X equals 12? I think that's wrong. Landon, do you have something? This one's a decimal. Yeah.
I knew that.
This one is a decimal.
got it.
You got it?
I think so. Can I say what I think it is?
Sure.
13.83.
Yeah, that's it. 3 repeat.
3 repeating, yeah. Okay, let's talk about y, where it comes from, okay?
Put weird numbers.
What do we know about these two?
They equal.
They are supplementary. They are alternate or same side exterior. Anytime you have same side, whether it's same side interior or same side exterior, that means supplementary. Same side, supplementary. Same side, supplementary, right? So we know that they're supplementary, which means if we write up an equation for them, it has to be this one plus this one equals 180 degrees, right? So now we do the math. 7x and 5x is 12x. Negative 5 and 19 is 14. We're going to subtract 14 from both sides. 12x equals 166. And then when you divide by 12, you get that x is 13.83, and the 3 is repeating. Chris, what's that big eyes for?
That was a lot to take.
That was what?
A lot to take in.
Did I go too fast?
Oh, maybe.
Did you get the equation part down?
Yeah.
Okay.
I don't know. It just looks like.
Add like terms.
Yeah.
Yeah, it's just basic equation solving. You got that stuff. You can do that basic equation solving stuff. Okay, y'all try 10. Let's see if y'all can do 10.
Well, they could
What?
They could have made this graph.
Well, I feel like they just couldn't fit the numbers in there, so they drew arrows.
But they're still
Yeah. Yeah, they do. Do you think that's bad? Wait till we get to the proof at the bottom.
Ooh, I'm still bad. Okay. I'm still bad.
All right.
I don't have a paper.
You don't have a calculator? Yeah, you do. Right here. It's in your brain.
I want to do long division there. Or not that. Yeah. I think I did it right there.
What math do you think it is? I mean, what are you trying to not do in your head?
I just.
I was going to tell you what it was. That's a really neat looking shirt, hoodie, whatever you. Was that a shirt or a hoodie?
Hoodie.
I like that.
How many years? They have had.
That's really pretty. Hmm.
Train just has to grow.
Probably bought it big, hoping that he could wear it a few years and grow into it. That's what I used to do with my kid. I'd buy everything a little big. Then she'd wear them till it was really too small.
Last year, I started out medium. This year, I started out extra large.
Oh, you grew that much since last year? Wow. Mm-hmm. Mm-hmm. Mm-hmm.
I don't even grow big, I just grow small.
Just get taller. Okay. Did you get an answer? What'd you get?
I got the 19.
19? Did you get 19? Let's talk about where it comes from, okay? What do we know about these two angles right here? What do we know about them?
They are inside and two.
And what do we say about same side angles? Same side? Supplementary. Uh-huh. It's exactly like the last problem. So you're going to... Huh? So you're going to set it up where you add them together and they equal 180. And then you combine your like terms. So 3x plus 5x is what? 8x. What's 10 plus 18? 28. Okay, so far so good. Then we're going to subtract 28 from both sides. And that's going to give us 8x equals... So 180 minus 30 would be 150. But I add 2 back because it wasn't 30, it was 28. So 152, right? And then if I divide both sides by 8, you get x equals 19. And I'm not a genius. I don't know that off the top of my head. I remember it because y'all are the 5th time I've done this today. 4th time I've done this today. I'm thinking about showing 7th period the video. I'm tired. Yeah. Huh? They actually like watching the videos. They like it. And they, hey, 7th period, y'all enjoying the video? They do like, you know when you were little and you watched like Dora the Explorer and you yelled back at the TV and stuff?
I hated Dora.
I love.
She was so annoying.
My daughter loved Dora. They do that. What? He pretended Dora was his girlfriend? Okay, let's go ahead and look at the bottom. Let's look at this proof down here, okay? We're going to wrap this up. And then y'all will work on your practice tomorrow. You can work on it today after we finish this because we'll probably have a little bit of time, but you don't have to, all right? Okay, so it says, provide a reason for each statement in the proof of Theorem 3.7. So they give you this information. Angle 1 and angle 2 are complementary. What does complementary mean? They add up to 90 degrees. So that tells us that 1 and 2 add up to 90 degrees, right? Okay. And then they tell us that BC, that's this segment, and CD, that's this segment, are perpendicular. That's that symbol right there, perpendicular, right? The little T. What does that mean? They intersect at a 90-degree angle. That means this angle is 90 degrees also, right? Okay, so we need to remember that because we're going to come back to that in a minute. So, and then they want us to prove that BA, this is parallel to this. So we're proving. Now, they actually proved it. We just have to give the reasons behind each statement. So the first statement, BC is perpendicular to CD. What's that statement? What's our reason there? How do we know that? Okay, but back up. Just even more basic than that. How do we know BC is perpendicular to CD? It says it right there. So whenever they tell it to us, what is our reason for it? Given. So we put given for our reason. Okay? Now, the next one is kind of common sense, but we do have a geometric postulate that says it. The measure of angle ABC, so ABC, that's this angle right here, right? Equals the measure of angle 1, that's this little angle, plus the measure of angle 2, that's this little angle. Well, duh, right? If you have two little angles and you add them together, they make the big angle. It's the same thing with segments. Two little segments added together make the bigger segment, right? But we actually call this a thing. So it's actually called the angle addition. Does anybody know? Close. Postulate. Angle addition postulate. And then there's a segment addition postulate, right? If you had two segments together, they make a bigger segment. Number 3 says angle 1 and 2 are complementary. How do we know that? It's given. They gave us that information. Remember? Up here? Okay. Now, so here's where we start. So we've told a given thing. We've told a basic common sense thing. We've told another given thing. Now we're going to start doing some steps to prove. So the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Now, how do we know that? Because they're complementary. So our reason here is definition of complementary angles. Because we know they are complementary, we know that they add up to 90 degrees. Do y'all see how that works? So, angle 1 and angle 2 equal ABC. 1 and 2 are complementary. That means 1 and 2 add up to 90. That means ABC adds up to 90. So how did we get from here to here? Well, we just used substitution. We just said, oh, so if 1 and 2 add up to 90 and 1 and 2 add up to ABC, then ABC equals 90. Y'all see how that works? Then we said BA is perpendicular to BC. BA is perpendicular to BC. That's this segment is perpendicular to this segment. Well, how do we know that? Because they make a 90-degree angle. So how do we know this? Because of the definition of perpendicular lines. Because perpendicular lines make a 90-degree angle, and they make a 90-degree angle. Y'all with me? One last step, and then we're done. So right here, they gave us two lines were perpendicular. Then we spent a little bit of time proving two other lines were perpendicular, right? But look at what we got. Now we've got that BC is perpendicular to CD. And look here, BC is perpendicular to BA. So if you've got BC and it's perpendicular to one and perpendicular to another one, what do you know about these two right here? They are parallel. So how did we get there? Substitution. That's pretty simple, huh? Now, as far as these reasons go, if y'all come up with something that makes even slightly remotely logical sense, I'm okay with that. Okay? Something even slightly close. Even not even really close. Just if it makes sense, I'm okay with that. Okay? For every single one, I probably would not be okay with that.